Welcome back. In this video and the next one, we're going to finish up section 4.5, actually finish up all of the term 2 work that you're doing. We have a little bit more work we need to do with u-substitution. Last week you saw how to do those with regular antiderivatives. We have 2 variations we're going to look at this week. The first one is how to do a u-substitution with a definite integral. And for our first example, I'd like to take a look at the integral from 1 to 4 of x minus 1 cubed dx. Now, we could certainly do this problem by foiling things out and all that, but let's try to do this with a u-substitution. If we try to do this with a u-substitution, what's u? Well, u, remember, is always the inside piece. The inside piece over here is x minus 1, so I'm going to say u is x minus 1. What's du? Du is the derivative and differential form of x minus 1, so du is dx, which means I'm going to get the integral of u cubed du. Now, these limits of integration over here, those were x values. In fact, I'm going to write x equals 1, x equals 4. Because I've turned this problem from something with x's into something with u's, I also need to change these limits of integration from x values into u values. But very nicely, I have a formula that will do that for me. This formula over here tells me how I can change my x's into u's. When x equals 1, u is going to end up equaling 1 minus 1, or 0. When x equals 4, u is going to equal 4 minus 1, or 3. So my problem is going to become the integral from u equals 0 to u equals 3. No, normally we're not going to write the u equals, we're just going to write the 0 to 3 of u cubed. Let me go do this. I'm going to go integrate u cubed. I'm going to get u to the 4th over 4 from 0 up to 3. Now, since these are u values, there's no point to replacing the u with the thing that it stood for in terms of x's. Since these are u's, I'm going to write u equals 3, u equals 3, u equals 0, I can plug them in right away. I'm going to get 3 to the 4th over 4 minus 0 to the 4th over 4. This is just going to give me 81 over 4. And that is this definite integral, which is the same as this definite integral. By the way, this original problem, it wanted to find the signed area under x minus 1 cubed. Okay, x minus 1 cubed, that's a cubic function that looks like this. I want to go from 1 to 4, so it found this signed area. If I'm just integrating u cubed, or x cubed, from 0 to 3, it's like I'm integrating something like this from 0 to 3. Yeah, those things have the same area. It's just the same thing, just shifted. The idea is we find our u-substitution, we do our u, we do our du, and we make any adjustments if we need to. The new piece, though, is we're going to change our limits of integration from x values into u values. I'll integrate, I'll plug in my numbers, and I'm going to get my answer. I will not go back and replace this u with x minus 1. Make any more notes that you need to before I go on. Let's take a look at this one. Let's try the integral from pi over 4 to 2 pi over 3 of the sine of 2x dx. Please tell me what u should be and what du should be. So u is my inside function. U is going to be 2x. Du is going to be 2 dx. Oh, I need that, so I'm going to stick a 2 inside and a 1/2 outside and get that thing. And this is now going to become a half times the integral of the sine of u du. Please change those limits of integration for me. X equals pi over 4 becomes u equals what? 2 times pi over 4, or 2 pi over 4. Don't call it that, though. Let's call it pi over 2. And change x equals 2 pi over 3 into a u value, please. I think that should become 4 pi over 3. Now, we're going to integrate. What's the antiderivative of the sine of u du? I hope you said negative cosine u, which I'm going to deal with from pi over 2 up to 4 pi over 3. See if you can finish this. Do your plugging in. Evaluate, draw out your right triangles if that's how you do trig, or unit circle stuff if that's how you do trig. See if you can finish off this problem and send in your answer. Cosine 4 pi over 3 is negative a half, so negative a half. Cosine pi over 2 is 0. We're going to get a half times a half. I think your final answer should be 1/4. What's the signed area under this original problem? 1/4, which is the same as the signed area under that problem. I'll make this pause so you can finish copying. Have one more example. Okay, let's see. Let us do the integral from 1 to 4 of the square root of 5 minus x. Oh, that's not on the screen, sorry. The integral from 1 to 4 of the square root of 5 minus x dx. Tell me what u is, and tell me what du is. U is going to equal 5 minus x. Its derivative is negative 1 dx, which means I'll have to stick a negative inside and a negative outside. Negative 1 inside, negative 1 outside. Tell me what those limits become. X equals 1 becomes what? X equals 1 becomes 5 minus 1 becomes 4. X equals 4 becomes 1. I'm going to get negative the integral. X equals 1 became u equals 4, so a 4 down there. X equals 4 became u equals 1, so a 1 up there. Square root of u du. Now, you're probably looking at this and realizing you don't like this very much. You want the 1 on the bottom, the 4 on the top. You're absolutely welcome to switch that and switch the sign of your integral to do the integral from 1 to 4 of the square root of u du. Totally fine. However, by my first fundamental theorem of calculus, I actually can leave those limits of integration as they are, and the signs will just get taken care of in the work for me. So here's what I mean by this. I'm going to get negative. Okay, integrate u to the 1/2. That's u to the 3/2 over 3/2 from 4 up to 1. That is negative. Oh, let's see. I'll move that 2/3 up front. U to the 3/2 from 4 up to 1. Negative 2/3 times 1 to the 3/2 minus 4 to the 3/2. You finish this and send in your answer, please. Negative 2/3 times 1 minus, okay, square root of 4 is 2. Cubed gives me 8. Negative 2/3 times negative 7, I am thinking 14/3. If I chose to not do this problem, but instead rewrote it as just the regular integral from 1 to 4 of the square root of u du, I'm not going to go through those calculations right now, but you'd get the same answer. The point is, if you're trying to do a definite integral analytically, doesn't matter what number's on the top, what number's on the bottom. If you have a graph, you always want to go from the lowest to the highest. But analytically, using our first fundamental theorem of calculus, just plug things in and your signs will get taken care of for you. The biggest thing to remember with these u-substitutions with definite integrals is make sure you're also changing the limits of integration.